All right, so next up, we're going to just kind of continue going through. So we have example 3. That's kind of the example that I had used on the very front page, though, but we can kind of walk through it real quick. So again, the first thing you want to do when given an example or a sequence of numbers is you want to figure out how are those numbers related. To go from 3 to 6 to 12, you are multiplying by 2. So if the terms are connected by multiplication, it's going to be geometric. And if it's geometric, that means you have a common ratio, or this R value, and since they're multiplying by 2, the R value equals 2. So the explicit formula says to find any term, so A sub n equals the first term, in this case, my first term is 3, multiplied by R raised to a power. So my R was 2, and it's going to be to the n minus 1. Now, remember, you cannot multiply those things together. You may not multiply those two things together. You will get the wrong answer. So you leave your answer like this if it's asking for the nth term. How is that different if they ask for a specific term? Well, if they asked you, say, for the 10th term, then you would plug in n equals 10 and then solve. But remember, PEMDAS rules apply, and you may not multiply those two together. All right, let's take a look at example 4. And again, our goal here is still to write an equation for the nth term, which means n is going to be in our answer. So from 2 to negative 3 to a positive 9 over 2. So those first 3 examples, it was pretty easy to see how the list or how the sequence of numbers was related. This one is a little bit harder to figure out how the list of numbers is related. So you can go back to the definition of what it means to be arithmetic or geometric. So one big clue that it's geometric is that it is alternating signs. See how it's positive, then negative, then positive? That is a huge, huge clue that it's geometric. So to figure out your R value, remember, R equals the second term divided by the first. So second term divided by the first. Now, just imagine this is the R value, then just check it. If you take this second term and you multiply it by this R value, so negative 3 times negative 3 is a positive 9 over 2. So you can tell that that's your R value because to get to the third term, you take the second term and multiply it by R. Another way you could do it is take this third term and divide it by this. Okay, so if you take this divided by negative 3, you would get negative 3 halves. Okay. So that's another way that you could check your R value to conclude that it's geometric. Since it's geometric, you have an R value, not a D value. And we already concluded that that was negative 3 over 2. And so you're just dropping that into the formula. You cannot clean that formula up anymore. That's as clean as you can get it. Okay. All right, we'll just scooch this up so we can see example 5 and 6 here. Okay, again, we have this going from negative to positive to negative, so that is a big clue that it's geometric. So I wrote geo there. Again, you could just circle it. And to get your R value, you do second term divided by the first term. So if you do that as 12 divided by this, right, 12 divided by this goes into there negative 2 times, right? So you can kind of reduce that fraction. That's how I got this R value. Now, if you did not have a calculator, you'd be fine kind of leaving your problem like this, but this one says to find the 11th term. So we go to find the 11th term. It says A sub 11 equals first term, which is that, the R value raised to the 11 minus 1, because it's n minus 1. If I'm trying to find the 11th term, that means this exponent is going to be a 10. So this would be a calculator question. So on your calculator, if you wanted to type this in, you'd get 32, okay? And then you would multiply those two. You'd multiply negative 6 by 32 to get to here. That would be your answer without the decimal, and if you had it with the decimal, that's what you'd get there. I would consider that to be a little bit more of an advanced question. So that one's a little bit harder. Okay. Next, we have to find the 102nd term. So again, if it was just asking you for the 4th or 5th term, it'd probably be easier just to look at the pattern and be like, oh yeah, I could just figure it out. But if it asks you for the 102nd term, you probably don't want to sit there all day and have that list going and going and going. So the first thing you do is try to identify what's the pattern, what's the relationship between 16 and 7, and then does that same relationship hold to go from 7 to negative 2? So it looks like I'm subtracting 9 to get there. So if they're attached by subtraction, it's going to be arithmetic. And so it's arithmetic there, and that means I have a d value in here because I'm subtracting the d value is negative. So we have that. I'm trying to find the 102nd term, so that's going to be my first term with 16 minus d parentheses. If I'm trying to find the 102nd, it's 102 minus 1 or a 101 there. So you can kind of clean this up. I've seen people do it both ways. I would probably consider this a 101 and then multiply it by 9, but you can distribute that 9. Either way, you should end up with the same answer of negative 893. You could check that if you don't believe me on there. Okay, so what comes next? We've got 7 and 8. So when taking a look at this list of numbers from 11 to 14 to 17, looks like I'm adding 3, and it's asking me to find the 241st term. So because they're related by addition, so a way to remember that is arithmetic and addition both start with A, so it's arithmetic, and the d value is a plus 3. So you have your formula. Again, here's the formula for that explicit. It says to find any term, you take the first term, and then you add it to the product of the d value and 1 minus the term number minus 1. So I'm trying to find the 242nd term. So that's the term there. That means that the n value is 241, so that goes there. The d value we determined was a positive 3. And again, to get that, you could do 14 minus 11, or you could do 17 minus 14. Notice how you get 3 both times there. And I would do 241 minus 1 is 240. 3 times 240 is that 720, and you just add 11 to get 731 for your final answer. So here, fractions are another indicator. So just like before how I said if you see it go from positive to negative, alternating like that, that's a clue that it's geometric. A lot of times fractions, you can have them with arithmetic, but if you see fractions that are changing denominators like that, that's a clue that it's probably geometric. So to figure it out, you do the second term divided by the first term. So you could do a little keep change flip there. A negative divided by negative is a positive. So my r value is 2/5 there. Again, geometric means you have an r value. And then I just take that 2/5 and plug it in. Now again, you're going to need your calculator here. You may not multiply those. You have to follow PEMDAS. So it's 2/5 raised to the 8th. Then that answer multiplied by negative 4. And if you do that, you'll have to use your calculator to get that little decimal there. Okay? And that is the end of the second page. Okay, example 9, you're given the sequence of numbers to be 0, 3, 8, 15. So then you're like, that list of numbers, like to go from 0 to 3, you add 3. But if you add 3 to 3, you'd get 6. You wouldn't get an 8. So you're like, how is that list of numbers related? Well, I would actually maybe do number 10 first, because if you look at 1, 3, 9, and 16, we kind of talked about that on the first page. That's not geometric or arithmetic, but they're all perfect squares. So your equation would be that a sub n equals n squared. Well, now, if you look at this list of numbers compared to that list of numbers, you'd see that these are all 1 less than a perfect square. So how would you represent that? You just say that any term can be represented by taking the term number and subtracting 1. So for example, the first term would be 1 squared, which is 1, minus 1 would give me that 0. The second term would be 2 squared is 4, 4 minus 1 is 3. So that's how I got that. Okay, so we kind of talked about those two. These next examples are still going to use that explicit formula, but instead of asking you for a specific term number, they're going to say that the 31st term in a list of numbers is 197. They give you the common difference, and they want you to go back to find the first term. Well, you have this formula, so given any 3 of the 4, you can figure out, you could solve for the other one. So here, we're given this 197. Now, the problem that people make here is they don't put the 197 in. So this is the 31st term. So you put the number there. The 31st term is 197. I don't know the first term, so that's why that's a sub 1. Plus, the common difference was a positive 10, so that's a plus 10 there. And then this number here is the n, so it's 31 minus 1. So that's going to be 30 times 10, gave me this 300. And now I'm solving for a sub 1, so you just subtract 300 from each side. So this says that the very first term in the sequence that was related by a common difference of 10, that the 31st term was 197, the first term must have been negative 103. Okay, so you're just solving for any part that's there. All right, here they're giving you the sixth term, so this tells you that n equals 6, okay? A sub 6 is this number, and your r value is 3. So here's your explicit formula. You're just plugging in. So the 486 equals the first term is what I'm trying to solve, and then it's 3. This is 6 minus 1. So really, you're trying to figure out whatever 3 to the 5th power is. 3 to the 5th power is this 243. That's related to this a sub 1 by multiplication. So to undo it, you divide both sides, and you get that your first term must have been 2. How could you check that answer if you wanted? Could you start off and just write 2 and then multiply by 3, right? That times 3 would give you 6. That times 3 would give you 18, right? And you could keep going, and I bet you the sixth term would be that 486 number, okay? So you could kind of extend that out if you wanted to. All right, just a couple more examples here. So we're given the first term, and we're given that to find the next term, you take the term before it and add 10. Generate the first 5 terms. So they told me a sub 1 was this, and they're giving you the recursive. They're saying to find any term, take the term before it and add 10. That's undercover telling you that this value is your D value. So negative 3 plus 10 would give me 7. Add 10 to that, add 10 to that, add 10 to that. That would be how you would generate the first 5 terms of the sequence. All right, for 14, very similarly, they're telling you that the first term is 5, so you start off with a sub 1 equals 5. And they're saying to get any term in the sequence, take the term right before it and multiply by negative 2. That's the recursive formula. So you just have to say the second term. Well, you take the previous term, multiply by 2. For the third, you take the previous answer, multiply by 2. Previous answer, multiply by 2, etc., etc., and that'll get you that list of terms there. Okay, the last two are definitely the ones that students struggle with. And there's a couple different ways to do it. So I think that the easiest way to do it is basically you are going to have an adjusted formula. So normally they will have to tell you what it is. So they will tell you if it's geometric or arithmetic. So the geometric, remember, this was the formula that we were using. It said a sub n equals a sub 1 multiplied by r to the n minus 1. So what I would need to do here is basically adjust this formula because now I'm not given the first term and I'm trying to adjust it. So I have an a sub 2 and I have an a sub 5. So what I'm going to do is I'm going to say, how would this relate if I basically changed it to an a sub 5 has to equal, well, I don't have an a sub 1. What do I have? I have an a sub 2, okay? And I still know it's going to be multiplied by r, but notice how this is n minus 1. See how it's this minus that number is your exponent? So it's going to be 5 minus 2 is what's going to go up here, 5 minus 2. So just like in this formula, it's n minus 1 there. So if you're trying to set it up to solve something differently, it's whatever this is minus that. So if I have an a sub 5 and an a sub 2, then my exponent on the r changes to 5 minus 2. Once you plug that in there, okay, so we know that the second term is, or the fifth term is 24, and that the second term is 3. We're trying to figure out the r, okay, because we still don't know that, and we do know that this exponent there could be 5 minus 2, which is 3. So you're like, okay, so that gets me to here. I'm trying to get r by itself, so divide both sides by 3, so I get 8 equals r cubed. Undo cubed, take the cube root, so I get a 2. The problem is the question says write the explicit formula. So the explicit formula is this one up here. Like they want to know a formula that will work all the time to generate any entry in that list of numbers. So I then need to take this r value and plug it back in to the original formula. To find any term, you take the first term, which you're like, I don't know it, so I have to do some side work to get it. But I know my r value is going to be 2 to the n minus 1. So this is kind of the general, but I needed to get this 1 1.5. So how did I get that? Well, I knew that the second term was 3. So if I wanted to find the first term, it's going to be kind of using the same thing. If I know that this is a 2, it'd be 2 minus 1. So that gives you a 1, so 2 to the first. Well, 2 to the first is just 2. So that tells me that 2 times